In this lesson, we're going to continue talking about properties of parallelograms, rhombi, squares, and rectangles. In this first slide, I'm giving you generic pictures yet again, and we're going to try to figure out the best name for each quadrilateral. So in this first picture, I look at what they've given me, and I want to try to think about the properties. Well, they've told me the diagonals are perpendicular. I can also tell that all the interior angles have been bisected, but they're also all exactly the same. So this part tells me rhombus, but also the fact that the interior angles are bisected and all congruent tells me this has to be a square. Anytime you have all 8 of these angles being the same, that automatically makes it a square. The second figure, all I see is that diagonals are bisected, which tells me it's a parallelogram, but they're also congruent to each other. Well, the figure that has congruent diagonals that's a parallelogram, well, those are rectangles, and this is just one, so that would be rectangle singular. So you're going to have some practice problems on identifying the figure just based on the markings. So you need to make sure you're studying all of your properties every night like we talked about in class. The other kind of problems we're going to look at, I'm going to skip that page for a moment, are problems where I give you, having all kinds of technical issues here, I'm going to give you 4 ordered pairs, and you're going to give me the best name for the quadrilateral. Well, to do that, we need to find the slope and the distance formula, and we need to review some of the rules on slope and distance given specific information. And what I mean by that is back in Algebra 1, you learned specific things about parallel lines and perpendicular lines. Well, parallel lines have the same slope. So anytime you get the same slope, that tells you the lines are parallel. So if we have an opposite sides parallel, we know it's going to be, if it's both pairs of opposite sides, then it's going to be some sort of parallelogram. Perpendicular lines have negative reciprocal slopes. And what that's going to tell me is where I have right angles. So we want to think about what kind of figures do I have right angles for? Well, I know that rectangles have right angles. I also know squares have right angles. So that's going to determine that one of my shapes could be a square or a rectangle. We will eventually, not today, identify right trapezoids as well. So let's talk about what the formula is for slope. Remember, you find the difference of the y's over the difference of the x's. That was your formula you learned in Algebra 1. Distance we learned in semester 1. That was on your first semester exam, and we will continue to use it. The distance formula was this, but remember, I also used Pythagorean theorem. And to find A, I subtracted my x's, and to find B, I just subtracted my y's. To me, that's a much easier method. It is still the same thing as the distance formula. So let's look at what this problem is going to look like. Okay, so let's look at our first example problem where we're going to have to find this information. Now, sometimes I'm going to give you the coordinate plane so you can graph it. Sometimes I won't. If I do not give you the coordinate plane, what I want you to do is draw a generic box, label it with your points, and then we're going to label our picture. So I'm going to do EF first. If I find slope of EF, I take my ordered pairs, -4 minus -1 over 3 minus 1. I get -3 over 2, so the slope of this is -3 over 2. Then if I want to find distance, or the length of the line, on EF. I do 1 minus 3, which is -2, and I'm going to make it positive because I know it's a distance. -1 minus -4, which is 3. When I simplify this, I get 13, so I can just put square root of 13. You could also write it as a decimal for this instance. I'm not going to hold you accountable for exact form on these. I'm just looking for either exact form or that. You just want to be able to tell when you have the same distance. Now you pause this and try to find the other measures and check it in a second to see if you get the right answers. Okay, so I found all of my slopes and I found my distance. Now, the lines that have the same slope, I know are parallel. So I'm going to mark those with arrows. They all had a distance of root 13, which is equivalent to 3.6. That means all sides are congruent. So it could be a rhombus, it could be a square. But I'm going to look at the special relationship between these two. Those are negative reciprocals. What that means is there's a right angle there. Then I look from here to here, another right angle. Here to here, another right angle. And here to here, another right angle. So you have a quadrilateral with all four sides the same and right angles. That must be a square. This one you don't have to do any work. We just want to label our picture. So MNOP, these have the same slope. These have the same slope. So I mark those parallel. These are congruent. These are congruent. These are negative reciprocals, as are these, and these. So I've got right angles, opposite sides, congruent, and parallel. So that's not enough to tell me I have a square with the right angles, but what I can say is that I have a rectangle. So I have one more example that I want you to go through. So once again, I'm going to get you to pause, work this out, and then check your answer. You can also plot these points to help you see it in the coordinate plane. Okay, so you should have gotten that you have a rectangle. Remember that 0 and undefined are reciprocal slopes. When you divide a number by 0, you're going to get undefined, versus 0 divided by a number is 0. So that's what made the right angles. And then you had opposite sides congruent and opposite sides parallel. So it is a rectangle. So your assignment is going to be some practice on the quads in the coordinate plane and identifying the special quadrilateral, and then potentially some sometimes, always, never.